All right, let's dive straight into this explainer. We're tackling a problem that has literally intimidated countless test takers, the variable heavy average speed question. You definitely know the exact type of problem I'm talking about, where instead of giving you nice, clean, easy-to-digest numbers, a test throws unknown percentages and total mystery distances your way. Honestly, it can feel like hitting a brick wall. But today, we're going to break right through that wall by completely demystifying the algebra behind it.
So here's our roadmap for today. We've got 1, the average speed trap, 2, defining the two legs, 3, calculating leg times, 4, finding a common denominator, and 5, the final simplification. We're just going to peel back the layers of this algebraic puzzle step by step. Let's get right into it. Okay, section 1, the average speed trap. Let's just confront the chaos head-on. I mean, just look at this handwritten scratch pad. Notice how visually overwhelming Francine's trip looks when it's all scribbled out with variables like x and d, representing unknown percentages and distances. The problem tells us she traveled x% of a total distance d at 40 miles per hour, and then the rest of the way at an average speed of 60 miles per hour. When you actually start mapping this out on paper, yeah, the page fills up incredibly fast, and honestly, that panic can really set in.
But to avoid getting completely lost in a sea of algebra, we have to anchor ourselves to this single, beautifully simple rule straight from our source material. Average speed is always total distance divided by total time. You see, it is absolutely not the average of the two speeds. Please never fall for that trick. It is strictly the total distance over the total time.
Moving right along to section 2, defining the two legs. The crucial thing here is we literally can't find the total without first breaking the journey into its two distinct parts. So this table kind of structures the chaos from that scratch pad we just saw. We define our total distance as d. The first leg covers x% of d at 40 miles per hour, and the second leg covers the remainder at 60 miles per hour. Let's look really closely at how we actually write that out mathematically. Since x is a percentage, we write the first distance as x divided by 100 and then multiply that by d. And for the second leg, well, if the first part was x%, the rest of the trip has to be 100 minus x%. So the second distance is d multiplied by the quantity 100 minus x all over 100. By defining these expressions cleanly right off the bat, we set ourselves up perfectly for the next step. Distance 1 is simply dx over 100. Distance 2 is d times the quantity 100 minus x all over 100. Boom! We now have a rock-solid grip on our speeds and our distances for both halves of Francine's journey. All right, section 3, calculating leg times. Let's see how this all builds together, because now we need to find the time for each leg to eventually get our total time.
We're going to reach right into our rate time distance toolbox and pull out this specific variation of the formula to solve for time. Time equals distance divided by speed. You know this one. It's the absolute key to unlocking the whole problem, and we're going to apply it systematically to both legs of the trip. So, plugging in our values for the first leg, we divide our distance by 40. Remember your fraction rules here? Dividing a fraction by a whole number basically just means you multiply the denominators. So, 100 times 40 gives us 4,000, resulting in the nice little fraction dx over 4,000. And there it is. That is the exact time Francine spent on the very first part of her trip.
Now, doing the exact same thing for the second leg gives us a time of d times 100 minus x all over 6,000. We just take the distance divided by her speed of 60 miles per hour, multiply those denominators, and we get this neat, well, okay, slightly bulky expression.
Which brings us to section 4, finding a common denominator. I know, here is where most people start to panic a bit, but we are going to completely conquer these fractions right now.
This brilliantly illustrates how sticking to a structured, step-by-step algebraic process completely removes the fear of dealing with large, clunky numbers. To add our two times together and get our crucial total time, we obviously need a common denominator for 4,000 and 6,000. The lowest common multiple? That's 12,000. To get there, we just multiply the top and bottom of our first time by 3. Then we multiply the top and bottom of our second time by 2. After that, we literally just sum the numerators. So following those exact steps, we combine our two times into one master expression over 12,000, setting up our grand finale. We now have an expression for total time that reads 3dx plus 2d times the quantity 100 minus x, all sitting right there over 12,000. We've officially successfully built the denominator for our master formula.
And that leads us to section 5, the final simplification.
Now that we have our total time and our total distance, which remember is simply d, it's time to bring this whole thing home.
Okay, we plug our terrifyingly complex fraction back into our master average speed formula, directly replacing total time. Remember our overarching rule from earlier? Total distance over total time? Notice how we've distributed the 2d in the numerator here, giving us 200d minus 2dx. This sets us up perfectly to clean up the top of that fraction.
By combining the like terms in our numerator, 3dx minus 2dx simply becomes just dx. And this allows us to elegantly factor out the variable d entirely. Look at the right side for a second. Because both terms in that numerator share the variable d, we can literally just pull it out to the front, giving us d times the quantity x plus 200. I gotta say, this is where the absolute magic of algebra really shines.
And because we are dividing by a fraction, we just multiply by its reciprocal. Watch as the mysterious total distance variable, d, beautifully cancels itself out. We flip the bottom fraction upside down, turning it into 12,000 over d times x plus 200. The d on top and the d on the bottom totally vanish. Mind-blowing, right? We literally didn't even need to know Francine's total distance.
So the dust finally settles, leaving us with our final, dramatically simplified average speed for Francine's entire trip, 12,000 divided by the quantity x plus 200. It's such a stunningly concise answer, born from what looked like absolute scribbled chaos at the very beginning.
Now, while understanding the actual algebraic logic is incredibly powerful and really builds that rock-solid mathematical confidence, it does leave us with a pretty intriguing question about test-taking strategy to ponder next. On a heavily timed test, could you maybe bypass all of this by simply plugging in a real number for d, say 100 miles, and a real number for x, like 50%? Well, the short answer is absolutely yes, but executing that shortcut is a completely different art form entirely. Try to figure out how you do it on your own and keep analyzing the structures behind these problems. I'll catch you on the next explainer.